Good morning, everyone. Today we will delve into the interesting topic triangles. We have covered first exercise of this chapter and we will focus a very interesting theorem. Before this, we should understand what is similarity of triangles. Clear? We should understand what is similarity of triangles. The two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same, such that if we draw two triangles and if their angles are equal, if their angles are equal such that these angles are equal. Clear? These angles are equal, then this will be in the same ratio. This will be in the same ratio. Clear? This side will be in the same ratio. That is the property. Clear? Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Now, what are equiangular triangles? What are equiangular triangles? That is the point. Here we are defining equiangular. That means there will be a triangles there and angles will be the same, equal. Then if the corresponding angles of two triangles are equal, then they are known as equiangular triangle. Here angles are equal of the triangles, then we can say that equiangular triangle. Clear? Equiangular triangle. Now, basic proportionality theorem. What is basic proportionality theorem? That is known as Thales theorem. Now, here, look at this figure. Look at this figure. We should draw a new figure such that here suppose we draw a figure. This is the line. Now this is the second line. We draw this line, and if we choose some points, clear, and if we this is A, this is B, this is C. If we meet both lines with the help of first we draw a line, and if we meet each other A to B, this line is point of this line is D and E. D is the intersection point of line AC and E is the intersection of the point of the line AB. And if we draw again a new line which is parallel to ED, then length of AE length of AE. This is ED. Suppose this is FG. Clear? Suppose this is FG. Then thales says that AG upon AE, AF upon AD are equal. AG, AE upon AG equal to AF, AD upon AF. That is the property. That is the property. Clear? This is known as, if we draw any other line up and parallel each other, then their ratio will be, upper ratio and lower ratio will be the same. That means ratio according line AB and line AC will be same. Clear? This is the property of Thales theorem. Here, look at this figure. AY, AX. Clear? That is the point. So this is the basic proportionality theorem, which is known as Thales theorem. Now, here the most important theorem, 6.1. If a line, first we should understand what theorem says that. If a line parallel to one side of a triangles, okay, to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. What is the given point here? If a line drawn is parallel to one side, this is ABC is the triangle. Clear? And DE is the parallel line of one side of a triangle BC. Clear? Where D and E the intersection point of AB and AC. Clear? Now, the other two sides are divided in the same ratio. We should prove here, to prove what is the proof? AD upon DB equal to AE upon EC. We will have to prove. Clear? This is the point. To prove. How can I prove? Before this, we should know some basic and essential information which will be very helpful to prove this theorem. Clear? First, if a line is drawn parallel to one side of a triangle, what happens? Clear? Then we will draw a perpendicular line. Clear? Here we will draw perpendicular line. Now, look at this figure. Clear? This is a triangle. Clear? Now, we should make another triangle. Here. This is another triangle. Clear? And these two lines, we should make new line on this board. Now, This is the common point. Now look at this figure. What figure here? This is the triangle, one triangle. Clear? This is the one triangle. And this is the another triangle between parallel lines. This is the another triangle between parallel lines. Clear? This is the another triangle between parallel lines. DE and BC are parallel lines. Do you know DE DE and BC are parallel lines? And do you know, if we draw a parallel lines and if we fixed 2 point BC and the third point of other side, opposite side, DE, we can take any point at DE which can be as taken as a variable. Then if we draw any triangles with two fixed point, then their area of those triangle will be same. How? This is the common point to understand. Suppose here this is a parallel line. Clear? This is a parallel line, and if we make any triangle, this is the fixed point, and we make a triangle. Now we will make a new triangle with two fixed point. Clear? And if we make any another triangle, suppose here we draw more triangles, and if height between these, suppose height between this is h. Clear? Between two parallel height, and this side is fixed. Suppose this length is fixed x. Then what will be the area? Area of, suppose this is a first triangle, this is a second triangle, this is a third triangles. Then area of one will be, area of one will be 1/2 base into height. Base will be x into height. Area of 2 as well as same, area of 2 base into height, 1/2 base into height. So this is the property of triangles between two parallel lines. So we should find out the area of a triangle BDE and area of triangle DEC. Clear? Here height is given that. Suppose this is H1 and the other line is H2. Clear? This is the point. NE is H1 and DEM is H2. Let's suppose that. Clear? Height of the triangle, because we enhanced the BD at A. Clear? This is the parallel line. AD and BD are a parallel lines. Clear? Now, here are two triangles. Here also ADE is a triangle. We can make area with two forms. Clear? In two ways. Area of AD will be, if we take base AD, then height will be this. If we take base AE, height will be H2. Clear? Now, we will find out the area here. Clear? Now, we have drawn a line. According to figure, what will be the area? Area of triangle ADE. Clear? A triangle ADE. What will be the area? We know 1 by 2 base into height. Here will be base AD and height will be NE. If we take base AD, then height will be NE. Clear? NE or EN. This is the point. Now we can write another point. Area, if we take base AE, then height will be DM. Clear? Height will be DM. This is the common point. Height will be DM. AE into DM. AE into DM. This is the common point. Now, we can make a condition like that. AD into EN equal to AE into DM. Clear? This is the result from this area. Clear? Now we will make another area. Area of triangle BDE. Area of triangle BDE. BDE. And height, if the base will be BD and height will be EN. Clear? Then area of triangle BDE. BDE. Clear? What will be the 1 by 2 base into height? What is the base? Base is DB. Base is DB. DB. Clear? D and B. This is the base. DB into height. What will be the height? Height of, if this is the base, then EN is the height. Now, clear? This is the point. And area of triangle DEC. Clear? And their height will be DM. Now DEC 1 by 2 DE 1 by 2 EC into DM. Here EC into DM. That is the point. Clear? Now we know area of parallel lines are equal. Clear? So area of triangle BDE equal to area of triangle DEC. Clear? Now both area are equal, then we can write 1 by 2 dB into En and 1 by 2 EC into DM. Then 1 by 2 dB into En, dB into En equal to 1 by 2 EC into DM, 1 by 2 EC into DM. Clear? Then we make new point. Here result will be such that 1 by 2 will be cancelled out and we got dB into En equal to EC into DM. This is the another point. Clear? This is the another point. We got point 2 and here point is 1. These are the two conditions. Clear? Now with the help of we can prove it. Clear? And do you know about this point? Point number 1 and point number 2. We should write here. Point number 1 and point number 1, what is? AD into En, AD into En equal to AE into DM, AE into DM. This is the point number 1. Now with the help of these two we can prove it. Clear? Now if we divide 1 by 2, then what will be the result? AD upon DB. Clear? Into En upon En. This will be cancelled out. Now AE upon EC, DM upon DM. Clear? Then we will get a new point. a new point is this will be cancelled out. Clear? Now we will get point AD upon DB equal to AE upon EC. This is the result. Clear? Of this theorem. I got this AD upon DB equal to AE upon EC. That means if you don't know about some common property which we have studied in previous classes, that in class 9th, then we cannot prove it. And if you try to prove it, then you will have no understanding about this theorem. So sometimes you maybe feel this is a boring theorem, but before we write, we can prove it. If you know between the parallel lines, if you fix 2 points and you draw many triangles, then area will be the same. That is the one point. And if you make one triangle and you create many heights, then the area will be the same. And with the help of these common points, we can prove this. Clear? That is the common understanding. This is the proof. Okay. So don't worry about this. Theorem 2 we will prove in next day. Thank you for your dedication. Thank you guys.